Brunelleschi'S dome, a legacy of ingenious engineering. At 12, Filippo Brunelleschi fell in love with technology and the challenge of constructing robust structures. This passion would spark an engineering revolution, allowing him to tackle one of the most significant architectural feats of his era, the dome for Florence's Basilica di Santa Maria del Fiore. The challenge of the dome in early 15th century Florence, a hub of Renaissance thought and creativity, the city aimed to crown its grand cathedral with a dome that could endure while reflecting its splendor. The initial design from prior architects was increasingly viewed as impractical. Tension mounted as the governing body, the Opera del Duomo, struggled with construction methods, especially traditional wooden centering, which was resource-intensive and slow. Concerns grew regarding the ability to support such a hefty structure. In 1418, Brunelleschi suggested a groundbreaking concept, a double-shell dome that could support itself during construction, minimizing reliance on temporary scaffolding. His bold idea was met with skepticism from contemporary architects, but Brunelleschi's thorough knowledge of geometry and structural integrity fueled his confidence. Context: Florence in the 15th century. Florence was richly traditional yet eager for innovation. The Renaissance brought remarkable artistic and scientific strides. The city's guilds held tightly to their established methods, and deviations faced resistance. Brunelleschi, not only an engineer but also a goldsmith and artist, blended aesthetics with functionality. Yet his ambitions clashed with traditionalism, favoring classical design. The engineering challenge of the dome. Brunelleschi envisioned constructing the dome using an innovative herringbone pattern of brickwork, allowing bricks to distribute weight downwards without external support. He proposed a dual-layer dome, an inner structure and an outer shell to shield from the elements while creating an iconic profile. Constructing a dome with a diameter of 42 meters posed formidable challenges. The sheer weight threatened potential collapse, and Brunelleschi meticulously planned logistics for sourcing and moving materials within contemporary economic limits. Step-by-step solution development. Brunelleschi's first step was determining the dome's geometry with interlocking arches to evenly distribute load. He then crafted a herringbone brick pattern for enhanced stability. Additionally, he invented a hoisting mechanism powered by pulleys and gears to lift heavy materials effortlessly. Throughout construction, he remained hands-on, refining techniques based on feedback and addressing unforeseen difficulties. He also designed external buttresses to mitigate environmental forces, blending innovation with traditional construction practices. Key systems and mechanisms. Brunelleschi's dome integrates engineering principles seamlessly. The oculus at the top serves both function and aesthetic appeal. The dual-shell structure provides insulation and resilience against storm-induced pressures. Circular arches effectively distribute loads, showcasing a revolutionary understanding of engineering through empirical knowledge and intuitive design. Difficulties and breakthroughs. Substantial challenges arose, particularly in preventing the inner structure's collapse. Brunelleschi's temporary wooden centering ultimately validated his herringbone approach when the inner dome held firm. Though contemporary architects doubted his no-scaffolding concept, the moment of joining the two shells proved a validation of his vision. Project hurdles included funding issues and labor strikes, which required negotiation with guilds. The design had to evolve continually to meet economic realities, illustrating Brunelleschi's adaptability. Real-world impact and significance. The dome's completion in 1436 represented not only Brunelleschi's triumph, but also a new architectural era. His principles influenced future generations, inspiring iconic structures globally, including St. Peter's Basilica and Byzantine designs. Modern engineers still study Brunelleschi's methods for insights into resilient, environmentally responsive design. Projects like the Sydney Opera House and the Millennium Dome reflect his enduring legacy. While today's tools replicate some ideas, Brunelleschi's fusion of art and engineering remains unmatched. Reflective closing. Brunelleschi's dome transcends Renaissance Florence, symbolizing how innovative engineering can transform adversity into opportunity. As we embrace technological advancement, his legacy guides our commitment to crafting sustainable, enduring structures. The dome crowns Florence's skyline and epitomizes the unwavering spirit of human creativity and capability.